Meet Ted. Ted is a security guard supervisor who works for a leading security contracting company. When the company was starting out, Ted found it easy to keep track of where all his security guards were by manually requesting updates using his radio. However, since the company has grown, he's been unable to know where all his security guards are, or if guards have even turned up at all. This has resulted in him deploying security guards to disturbances which other guards were closer to, leading to an increased response time. Introducing Project Ghost. Project Ghost is a smartphone application for security guards who want the precise location of their employees. Unlike traditional methods like radio, Project Ghost generates real-time position locations of security guards automatically. Ted no longer has to spend crucial minutes deciphering locations to determine who to deploy. Project Ghost uses already installed Wi-Fi access points to create a map of your building, so to set it up, all Ted has to do is open his app, pick the building and level, and then choose a sector and walk around the perimeter. Once set up, Ted can then see whenever one of his security guards is in that sector. Each security guard's phone tracks each Wi-Fi point, and using a specially developed algorithm, determines where they are within that building. This location is then sent to the cloud, where it can be viewed by co-workers and by Ted. By being able to precisely locate all employees, Ted can optimize the positioning and patrol paths of guards within the building, making sure two security guards don't cross paths, creating a more covered building and a happier Ted. To reduce computational load while also ensuring more reliable calibration data, Project Ghost was designed as a dual application system. The first application, Calibrate, is used by admin staff to create a virtual layout of the building, which is then pushed to the cloud. The second application, Locate, which is used by all other users, reads in the data from the cloud, processes it and determines the user's location, which is then re-uploaded to PASS to ensure each security guard's location can be viewed remotely. To calibrate a level, the admin staff have to split each level into a number of sectors. Once these sectors have been visualized, the admin has to go to one of the sectors, select it on the application, and walk around that sector. As the user walks around the sector, every time an access point is found, its MAC address and signal strength are recorded. The MAC address is compared to access points previously found within that sector. If it already exists, the signal strength is used to create a minimum and maximum signal strength values for the access point within the sector. Each access point found within a sector during calibration is then uploaded to PASS as a record, including the MAC address, the level and sector, and the max and min signal strengths. To reduce errors from noise, access points with the same minimum and maximum values are not uploaded. Using Locate to determine the user's location, each access point that is currently being picked up by the user's phone is compared against every record downloaded from PASS. If the current MAC address matches an entry from PASS and its signal strength is within the record's max and min values, the record's corresponding building, level and sector score are incremented. These scores are then compared for each sector. The sector with the highest score is the estimated location. Experimental results show the current algorithm can locate a user to the correct building 100% of the time, the correct level 99% of the time, correct sector or its adjacent sector 95% of the time, and the exact sector 80% of the time. During the testing phase of development, it was found that there is an area for improvement in the calibration application with regards to user feedback, and since incorporating that, we have a robust, accurate, easy to use product.